Okay, now students, now we'll see, you know, the AM receivers and FM receivers. Now in that one part, a local oscillator, okay, which will play the key role to get back the intermediate frequency from any incoming signal, right? So we just studied that local oscillator frequency in detail here. This is Fs. This is the mixer. Now here the mixer, the local oscillator, which is variable, the local oscillator frequency is Fl. This local oscillator is adjusted to maintain IF constant, right? Because Fl minus Fs, which is equal to IF. So now see here, this is possible when Fl is greater than Fs. Now see here, what is generally, this local oscillator is nothing but a Hartley oscillator, am I not? What is a Hartley oscillator? Now the resonant frequency of oscillator Fl, which is equal to 1 by 2 pi root LC, am I not? Then if you take AM range, what is AM range? 550 kilohertz to 1650 kilohertz, right? Now this 2 pi is constant, L is constant, so Fl is inversely proportional to 1 by root C. So Fl maximum, which is nothing but capacitance, is minimum. If Fl is minimum, means capacitor is maximum, right? So now what is this ratio? Fl maximum by Fl minimum. Now this is some constant cancel. So this is C maximum by C minimum. So square both sides, that root is cancelled. Fl maximum, this is square root of C maximum by square root of C minimum. So can I write like this? The maximum to the minimum capacitance ratio, which is square both sides, Fl maximum to the Fl minimum whole square. Now this is the maximum to the minimum capacitance ratio, which is equal to Fl maximum to Fl minimum, okay, the maximum to the minimum capacitance ratio. Now see here what happened. If now I'll just have two conditions. Fl greater than Fs is one case. So which is nothing but Fl minus Fs, which is Fl minus Fs is equal to IF. So here it is Fl, which is equal to Fs plus IF. But in this case, actually Fl minus Fs is equal to IF. This is Fl greater than Fs case. So in situation, Fl, which is equal to Fs plus IF. Now you tell me, what is Fl maximum? Fl maximum, which is equal to Fs maximum plus IF. How much? Which is nothing but Fs maximum is 1650 kilo. IF is IF, you know that IF, which is equal to 455 kilohertz. 455 kilohertz. Now for easiness, I just take 450. Okay, for easy calculations. So this is 450 kilo. So which is nothing but 2100 kilohertz. Now, what is FL minimum? FL minimum, which is equal to FS minimum plus IF. Now, which is nothing but 550 kilo plus 450 kilo, which is equal to 1000 kilohertz. So, what is the maximum to the minimum capacitance ratio? The maximum to the minimum capacitance ratio is 21,000 by 1000, kilo cancel, whole square. Now, the maximum to the minimum 21 by 10, which is nothing but 2.1 whole square, which is equal to 4.41, is approximately 5. Let us take 5. So, the maximum to the minimum capacitance ratio is 5:1. The maximum is 5 capacitance are sufficient to cover the range of 550 to 1650 if FL greater than FS. Okay. So, the low class oscillator frequency is continuously adjusted to maintain IF is constant for any incoming signal carrier frequency. Is it right or not? So, this is when FL is greater than FS. Why we should take FL is greater than FS? So, if FL is greater than FS, so the maximum capacitors are required is less, which is 5, and tracking is easy. So, if FL is not greater than, what happens we will see. Note down first. Okay. Now, I just write here now if FL is less than FS, what happens? If FL is less than FS, means FL FS minus FL equal to IF. So, here FL, which is equal to FS minus IF. So, now what is FL maximum? So, FL maximum, which is equal to FS maximum minus IF, which is equal to FS maximum is 1650 kilo minus 450 kilo, which is equal to 1200 kilohertz. Now, FL minimum, which is equal to FS minimum minus IF, which is equal to 550 kilo minus IF is 450 kilo, so which is nothing but 100 kilohertz. So, what is the maximum to the minimum capacitance ratio? The maximum to the minimum capacitance ratio, which is 1200 kilo by 100 kilo whole square. So, now you see here, which is nothing but 12 square, which is nothing but 144. Okay. So, the maximum to the minimum capacitance ratio is 144. So, now you tell me, maintain 144 capacitor at a time or maintain a 5 capacitors at a time, which one is easy? So, maintain 150 capacitors, which is very difficult, but maintain a 5 capacitors, which is very easy. Am I not? So, here That is the reason why FL greater than FS, which is always preferred. Okay, this is 5:1. Variable capacitors means varactor diode, variable capacitors, varactor diodes is used tracking is easy. Maintain 5 capacitors, which is very easy, but here tracking is very difficult. Tracking is very difficult. Now difficult to operate of 150 capacitors, and which is very difficult. Okay, now that is the reason why FL greater than FS, which is always preferable, no doubt. Practical implementation is not possible here, but here the practical implementation is easy. Okay, so this is the operation of local oscillator in the receiver. Okay, this local oscillator is adjusted to maintain IF constant to cover AM range or FM range, whatever it may be. It may be in AM receivers or FM receivers. Okay, now this is the local oscillator frequency, how it is operated in the receivers. Now why FL is greater than FC is preferable, why FL is less than FC is not preferable. Okay, this is the reason. Okay, and sometimes the question is asked, how many capacitors for this much of frequency, how many maximum and minimum capacitance ratio is also used, and this formula is also useful to you. Okay.